In this video, we'll talk about probability, kind of what it means and the different types of it, and we'll talk about probability of single events. So if we really think about what probability is, it's the likelihood that something will happen. So we're talking about percentages of the time or fractions of the time. So a couple of axioms. Remember, axioms are they're things that can't necessarily be proven, but they're things that are generally understood to be true. So, little notation for you here before we begin. This P of A, this would be the probability of whatever A is happening. A being some kind of event, like a coin toss, or rolling a die, drawing a card out of a deck, pulling something out of a sample. So it's just a way of saying probability of whatever A is, A being the event. So probability that a tail is flipped when a coin is tossed. Probability that a 7 is rolled between two dice, that kind of thing. So some axioms that we'll talk about. The first of which being that probability of anything happening, let's call it A, is between 0 and 1. Now if you think about this in terms of percentages, 0 is obviously 0%. And 1 is 100%. So what this is saying, essentially, is that the probability of anything happens is between 0% and 100%, which that seems to be a true statement, something that we can take as fact. Second axiom that we'll talk about today, and there will be others that we'll talk about as we progress, but these are the big two that a lot of probability is founded on. So if we're looking at this, the probability of not A, meaning the probability that A doesn't happen. So like, for instance, if I'm looking at this and I'm thinking about, okay, what's the probability that I don't roll a 4 on a standard single dice? That would be the kind of question we're looking at here. So the probability that A doesn't happen is going to be equal to 1 minus the probability of A. Which again, it would make sense, because all I'm saying here is that if anything but A happens, I have met with, let's call it success. So if I figure out what the probability of A happening is, and I take it away from all possible possibilities, which would be 100%, then that would tell me what probability that I don't achieve A is. And again, these are two axioms. We're just diving into the theory of it, and really these two things are fairly simple in their idea, and they're very helpful as we start to calculate probabilities. So again, the first one, any event is between 0% and 100%. And the second axiom, if I want to figure out what are the chances that something doesn't happen, I can just take the chances that it does happen away from 1 or 100%. Okay, a little more into the definition. There are two types of probability. There's experimental and there's theoretical. So if we're thinking about this, experimental is more of you do a series of trials. So let's consider a coin for a second. If I flip a coin 10 times and I get 7 tails and 3 heads, well, this tells me that there's a 30% chance of heads. Now, we know that that might not necessarily be the exact possibility of the thing, but based on our sample, that's what we have to say. So experimental is based on a sample, and it's something that isn't talked about too much when you're talking about probability on a more of a conceptual level. Experimental is more useful when you're looking at surveys, you're looking at data analysis, that kind of thing. So it plays a part. However, given sampling variability, it can't always be as accurate as we would like. So theoretical is where we spend most of our time, at least initially. So for theoretical, we figure out the chances or the number of opportunities for a success, and I'll put that in quotation marks, over the total possibilities. So an example of a coin, if I want to flip a coin and it comes up tails, what's the probability that it's going to happen? Well, there's one tail on a coin out of 2 total possibilities. So my probability of, say, tails in this case is equal to 1/2, 50%, 0.5. All of those would be perfectly acceptable ways of measuring probability. And this 1/2 is more geared towards what we normally think about probability when we think about a coin toss, as opposed to if we think about our experimental, which in the case would say 70% would be tails or 30% would be heads. So there's just a slight difference between experimental and theoretical. Theoretical, we're looking at, okay, theoretically, what would happen if all things are equal? What happens? And experimental is more based on a sample of what I have. Now again, the experimental, that's kind of more for data analysis. We're not going to look into that too much right now, but it's something I want you to be aware of at the moment. So let's talk about a couple of examples here where we can use our axioms of probability and we can talk about what we know, what we can talk about theoretically probability here. We're not so much worried about experimental at this moment. That'll be coming down later when we're talking about sampling, that kind of thing. So let's talk about a standard deck of cards. Overall, there are 52 cards. There's 4 suits. So there's clubs, hearts, diamonds, spades, and there's 13 of each. There's an ace through a king. If you consider ace to be the low one, if you consider 2 to be the low one, well then it goes through to from 2 to ace. Either way, there's 13 of each suit. So there's 13 spades, 13 diamonds, 13 of them, so on and so forth. There's 26 red, 26 black cards. And there's a lot of things that we can do with a standard deck of cards. A lot of the questions kind of revolve around this idea. So basically, a standard deck of cards is if you take the jokers out of a deck of cards, it's what you're left with. So 52 total, 4 suits in each, so on and so forth. Okay, so let's consider theoretical probability that I draw a heart. Well, let's call it probability of H for heart, just for short. There are 13 possibilities, because there's 13 hearts. I could pull the ace through the king of hearts and consider myself successful in that regard, out of the 52 total. Which, if you wanted to, you could reduce this to 1/4, and that would also make sense because 1/4 of the cards are hearts. Now, that's using what we know to kind of determine probability, and that's where the theoretical can kind of come in handy. It's when you know a lot about a thing. If we're talking about, statistically speaking, who's more likely to vote a certain way, that's where we would have to rely on experimental probabilities because we don't necessarily know what the chances are. But however, with this example, we do. So one more example here. Let's talk about a standard die. So this is your standard 6-sided die, numbered 1 through 6. And let's look at this idea a couple different ways. Probability that it's not a 6. So this meaning I can roll it, and as long as it's not 6, it's going to be fine. So if we think about it, there are 5 opportunities that it's not a 6. I can have 1, 2, 3, 4, and 5 out of the 6. So that would be the probability. Now another way we can think about it, the probability that I do roll a 6 is 1/6. Which, if you remember our axiom, I could take 1 minus 1/6, and that would be 5/6. Now, in this case, you might be asking yourself, okay, well, why wouldn't I just do it the original way and just think about the 5 cases? And to that regard, I would say in this example, you're right. You can just think about it. However, I picked this example because it is one that we do know a lot about. If it's something you don't know a lot about, if you don't know all the other possibilities necessarily, you might not be able to get there. And that's where this second method can be useful. So, given these kind of basic ideas, we're just going to be looking at different probability examples of single events, and we'll get more complex from there. But this is just kind of an intro lesson to get you started.